Hey y'all. So today's objective is common logs. We've been working with logarithms. And just a reminder, if you have a log base 10 of A equals B, then this base 10 is understood. So we're not going to write base 10 every time. But what this says is log base 10 of A equals B. And this IFF means if and only if. So the only way for this to be true, if and only if 10 to the B power equals A. So I know I showed you that loop last time. So what this means is 10 to the B power equals A, and then to undo an exponential function, you would take the log base 10 of A equals B, which means 10 to the B power equals A. So here are some problems. For example, if you have 10 to the X power is 100, that means X is 2, because 10 to the second power is 100. 10 to the X power is 1,000, so X is 3. If you have this one, 10 to the X power is 1/10. We need that 10 to go to the bottom, so we know our exponent is going to be negative, and it's going to be -1. X is -1. Now number 4, 10 to the X power equals -100. So I wrote a little stop. You can't have a negative as your answer. It's not possible. Not possible. The reason it's not possible is because if you have an exponent, 10 to the something power, 10 to the 1 is 10. 10 to the 2 is 100. If you have a negative exponent, it's just going to be a fraction. 10 to the -1 is 1/10. 10 to the -2 equals 1/100. You can't have a negative answer from an exponent unless your base is negative. But in all these cases today, we're going to be talking about a base of 10. So we're not going to be able to have a base of 10 come out to a negative answer. So if you have a negative right here, you know that that's not possible. Alright. So we're going to do some examples finding the value of X. So I put a little note over here. Log base 10 of A equals B. B to the 10 to the B power equals A. Now these are going to be problems that you can't just eyeball, meaning you're not going to know the answer because they're not going to be multiples of 10. So the first one, 10 to the X power equals 3.467. Some of these are going to be rounded. You're going to need a calculator, and this is where we're going to use the log function. Right up here, a log function undoes an exponential function, and if you have a base 10, then it's called a common log. That's the whole reason these are called common logs. If you have something written in exponential form, we're going to rewrite it in log form, and then we can solve it. So the way you would solve this equation, I'm going to show you two ways. The way you would solve this equation is you could rewrite it in log form, meaning log of base 10, and remember these two things kind of switch places, of 3.467 equals X. And then you would go to your calculator and you would type in log, the log button, 3.467, and we get 0.5399. So I'm going to round 0.54. Really, it's 0.53995. So that would all round up to 0.54. So that's one way. You can rewrite it in logarithmic notation. Another way you can solve it, let's look at number 2. 10 to the X power equals 345. I know it's going to be 10 squared is 100 and 10 to the third is 1,000. So it's going to be between 2 and 3. But I can't tell you exactly what it is. So we are going to solve it using logs. You can write it in logarithmic form, or you can do what's called take the log of both sides. If we take the log of both sides, oh, come in. Oh,
Are you taping it?
I am.
I'm sorry.
It's okay.
I'm continuing for Schuler Wednesday.
Oh.
And Ms. Timmons said there's videos available that we could watch.
There could be. Can I finish and then I'll come talk to you?
Yeah.
Okay.
Absolutely.
All right.
Yeah.
Yeah. So if you're taking the log base 10 of X, when you were to type that in, if you were to type in your calculator log base 10, it comes out to be 1. That's because it's common log. So if you take the log of both sides, essentially we are undoing it, we're canceling it, and we're going to be left with x. And then the log of 345 is going to be 2.538. I'm rounding, 2.5378819. These are all going to be, mega decimals. So 2.538. So you can write it in logarithmic notation, or you can just take the log of both sides, and then this brings down your x, and this brings down your answer. So look at number 3. 10 to the x equals 6.2. You can do whatever method you want. I'm just going to take the log of both sides, and I know this gives me x. And when I type in log of 6.2, it's going to be 0.7924. 0.7924. Number 4. 10 to the x power equals negative 3.45. You see this negative, so we would write not possible. Not possible. You can't have a negative answer if you have a base of 10, so that answer is not possible. Number 5. I'll show you in logarithmic form. So if we wanted to rewrite it, log base 10 of that equals x. So I've rewritten it using log form. And then I type in log of 0.0023 and x equals negative 2.638. I'm hoping that you're typing these in your calculator so you can get used to using the log function on your calculator. So I have shown you 2 different ways to solve it, either rewriting it in log function notation or taking the log of both sides. But hey.
Or you could just call Devin,
You know how to solve logs?
Oh, what video is this?
This is math 2.
Merry Christmas.
Merry Christmas.
Hey,
Happy
Jay.
New Year.
Hey, Michaela.
Okay.
Hey, Ross. Hey,
You're going to hurt everybody else's feelings.
Hey, Skylar. Hey, John. Hey, everybody else. Y'all have a great day. Bye, man.
Okay.
See you, man.
More examples. Find x. Alright, so going back, these are going to be a little bit more complicated, but I want to show you don't always have to do log. You can, but you don't always have to. In number 6, 10 to the 3x plus 2 power equals 1,000. Now we practiced this. If you can get it down to a base of 10, then your exponents have to be equal. So this is already a base of 10, and 1,000 is 10 to the third. So I know that my exponents are going to be equal. And then you could solve by subtracting 2 from both sides, and x equals 1/3. You divide both sides by 3. But I want to show you also that you can still take the log of both sides. If you take the log of this side, you're left with 3x plus 2. If you take the log of 1,000, if you type in log of 1,000, it gives you 3. So we're back to where we started. Either way, you can do it. You can get a base of 10, or you can just take the log of both sides. All right, example 7. Before we can do anything, I have to have a base of 10. And the way the problem's written, I do not have a base of 10. I have 2 times 10 to the x power. This would be like a real world problem. Y equals ab to the x. So I would divide both sides by 2. And now I have a problem written that I can deal with. You can take the log of both sides, or you can use what you know. 10 to the what power is 100, and x equals 2. All right. Number 8. I have a lot going on. So first I need to get 10 by itself. So I'm going to subtract 7 on both sides. And I get that equals 21. Then I'm going to divide both sides by 3. And I get 10 to the x plus 4 power equals 7. And I don't have a base of 10, so I'm going to use my log rules. I'm going to take the log of both sides. And I get x plus 4 equals log of 7, which I don't know what that is. 0.84551. I'm rounding. 0.84509, so 0.8451. Then it's x plus 4, so I subtract 4 from both sides. 0.8451 minus 4, and I get negative 3.1549. Okay? So let me just go back through that one more time. When you have an equation like this, we know we want to get a base of 10, then we can use the log function to undo it. I have to subtract 7 from both sides, then I had to divide by 3, then I can use my log function and I can undo that base of 10. Alright, so a couple more examples. Number 9, very similar. I'm going to divide both sides by 12, and I get 10 to the 3x plus 2 equals 10. Well, you have a choice. You can take the log of both sides, or you can see this is already a base of 10, which I know it's going to have an exponent of 1. So I know my exponents are going to be equal. Your exponents are going to be equal. If you have the same bases, your exponents are going to be equal. So I solve this. I add 2 to both sides, and then I divide by 3, and x is 1. You could also take the log of both sides, and you would still get the same answer. Number 10, 10 to the x plus 2 equals 43. This one's straightforward. I can't get a base of 10 using 43, so I'm going to take the log of both sides. And I get x plus 2 equals log of 43. So I type in my calculator, log of 43. And it's 1.6334, 1.63346, so 5. I'm going to subtract 2 on both sides. 1.6335 minus 2. And I get negative, sorry I cleared it, negative 0.3665. Okay? And I took the log of both sides. Now, to this final one, you tried. 10 to the 2x equals 50. I want you to solve that one on your own. You tried. Pause it, and then press play when you're ready to see. All right, I would take the log of both sides, and I get 2x equals log of 50. 1.69897, so that's going to be, make that go up, 1.699. When rounding, you're going to divide both sides by 2, and we get 0.8495. And if you notice, I tried to go out to 4 decimal places because a lot of these are going to be rounded. And if you go out 4 decimal places, you're going to have a smaller chance of error than if you just rounded 2 decimal places. So you'll notice I go out. All right, we'll practice more common logs later.